What's up guys, Jerome Bayani here from BSIT 2105, and for today's video is all about summarization of chapter 5 entitled Ethernet, so let's get going. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. Because Ethernet is comprised of standard at this lower layer, it made best to be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standard of the media. So there are two types of Ethernet sublayer. These are the LLC sublayer and the MAC sublayer. The LLC sublayer handles the communication between the upper layers and the lower layer. LLC is implemented in software and its implementation is independent of the hardware. MAC sublayer. MAC constitutes the lower sublayer of the data link layer. MAC is implemented by hardware, typically in the computer NIC. The specifics are listed in the IEEE 802.3 standard. So, MAC sublayer has two primary responsibilities. These are data encapsulation and media access control. Data encapsulation. The data encapsulation process includes the frame assembly before transmission and frame disassembly upon reception of the frame. The media access control. The second responsibility of the MAC sublayer is media access control. Media access control is responsible for the placement of frames on the media and removal of frames from the media. Ethernet frame fields. The minimum Ethernet frame size is 64 bits and the maximum is 1518 bits. This includes all bits from destination MAC address through the frame check sequence or the FCS field. MAC address in hexadecimal. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digit, or the 4 bits per hexadecimal digit. So, in Ethernet, every network device is connected to the same shared media. Ethernet was a predominantly a half-duplex topology using a multi-access bits or later Ethernet hubs. MAC address structure. The MAC address value is a direct result of IEEE enforced rules for vendors to ensure global unique address for each Ethernet device. Frame processing. The MAC address is often referred to a burned-in address or the BIA because historically this address is burned into ROM or the read-only memory on the NIC. This means that the address is encoded into the ROM chip permanently. MAC address representation on a window host. The ipconfig-all command can be used to identify the MAC address of the Internet adapter. So, unicast MAC address in Ethernet. Different MAC addresses are used for layer 2 unicast, broadcast, and multicast communication. A unicast MAC address is the unique address used when a frame is sent from a single transmission device to a single destination device. Broadcast MAC address. A broadcast packet contains a destination IPv4 address that has all ones in the host portion. Multicast MAC address allow the source device to send a packet to a group of device that belong to a multicast group that assigned to multicast group IP address. The range of IPv4 multicast address is 224.0.0.0 to 239.255.255.255. Switch fundamentals. A layer 2 Ethernet switch uses MAC addresses to make forwarding decisions. It is completely unaware of a protocol being carried in the data portion of a frame, such as IPv4 packets. The switch makes its forwarding decision based only on the layer 2 Ethernet MAC address. Learning MAC address. The switch dynamically builds the MAC address table by examining the source MAC address of the frame received on a port. So, filtering frames. As a switch receives frames from the different device, it able to populate its MAC address table by examining the source MAC address of every frame. When the switch MAC address table contains the destination MAC address, it is able to filter the frame and forward out a single port. Frame forwarding method in Cisco switches. Switches use one of the following forwarding method for switching data between network ports. These are the store and forward switching and the cut-through switching. Cut-through switching is the switch act upon the data as soon as it is received. Even if the transmission is not complete, the switch buffer just enough of a frame to read the destination MAC address so that it can determine to which port to forward the data. There are two variants of cut-through switching. The first one is the fast-forward switching, offer the lower level of latency. Fast-forward switching immediately toward a packet after reading the destination address because fast-forward switching starts forwarding before the entire packet has been received. There are many times when packets are relayed with errors. This occurs infrequently and the destination network adapter discard the faulty packets upon receipt. The second one is the fragment-free switching. In fragment-free switching, the switch stores the first 64 bits of the frame before forwarding. Fragments-free switching can be viewed as a compromise between store and forward switching and the fast-forward switching. Memory buffering on switch. An Internet switch may use a buffering technique to store frame forwarding them. Port-based memory buffering. In the port memory buffering, frame are stored in queues that are linked to specific incoming and outgoing port. So the shared memory buffering deposit all frames into a common memory buffer that all the posts on the switch share. The amount of buffer memory required by a port is dynamically allocated. Duplex and speed settings. Two of the most basic settings on the switch are the bandwidth and duplex settings for each individual switch port. There are two types of duplex setting used for communication on the internet network. These are the half duplex and the full duplex. Half duplex means only one end of the connection can send at a time, while the full duplex is both ends of the connection can send and receive simultaneously. Destination on the same network. There are two primary addresses assigned to a device on the internet LAN. The first one is physical address or the MAC address used for Ethernet NIC to Ethernet NIC communication on the same network. The second one is logical address, the IP address, used to send the packet from the original source to the final destination. The layer 2 Ethernet frame contains destination MAC address, which means this is the MAC address of the file server Internet NIC. The second one is the source MAC address. This is the MAC address of the PCA's Ethernet NIC. The layer 3 IP packet contains source IP address and the destination IP address. The source IP address, this is the IP address of the original source or the PCA. The destination IP address, this is the IP address of the final destination, the file server. Introduction to ARP. Recall that every device which an IP address on the internet network has an internet MAC address. When a device sends an Ethernet frame, it contains these two addresses. the destination MAC address, and the source MAC address. The destination MAC address, these are the MAC address of the Internet NIC, which will be either the MAC address of the final destination device of the router. The source MAC address, the MAC address of the sender Ethernet NIC. The ARP functions, resolving IPv4 addressing to MAC address. When a packet is sent to the data link layer to be encapsulated on the Internet frame, the device refers to a table in its memory to find the MAC address that is mapped to the IPv4 address. So, ARP messages are encapsulated directly with an Internet frame. There is no IP4 header. The ARP request message include the the first one is the target IPv4 address. This is the IPv4 address that requires a corresponding MAC address. The second one is the target MAC address. This is the unknown MAC address and will be empty in the ARP request message. The ARP request is encapsulated in the Internet frame using the following header information. The destination MAC address, this is the broadcast address requiring all Internet NIC on the LAN to accept the process the ARP request. The source MAC address, this is the sender of the ARP request MAC address. The type ARP message have a field of OX808. This inform that received NIC that the data portion of the frame need to be passed to the ARP process. So, when the destination IPv4 address is not on the same network as the source IPv4 address, the source device needs to send the frame to its default gateway. The IPv4 address of the default gateway address is stored in the IPv4 configuration of the host. ARP broadcast. As a broadcast frame, an ARP request is received and processed by every device on the local network. ARP spoofing. In some cases, the use of ARP can lead to a potential security risk known as ARP spoofing or the ARP poisoning. This is the technique used by an attacker to reply to an ARP request for an IPv4 address belonging to another device. So, this is all I can give you guys about the summary in Chapter 5. Thanks for watching. See ya!